第二次，所以咱们不多说了。下面呢，就请咱们大家以热烈的掌声，欢迎中心教授下来。
Okay, 你好。I'm going to speak very slowly today. And sometimes maybe Meg-san will translate. Sometimes you please translate some portion. Okay. Okay, let me start. Today's topic is this one. Climate conditions and their impacts on global crop yield, and also how to reduce greenhouse gas. 2 points. I will give a talk to you. Okay? And first of all, I'm now working at the Clancy Tertiary School of Policy Studies, Department of Media Informatics, Associate Professor. And also, I'm working as National Institute for Environmental Studies and Spatial Information Science at the University of Tokyo and Tonzin Tashi, and also the Hokkaido University. And Kitasato University and Jiri University has a strong relationship. I met Vice President yesterday, and he told me that he knows my friend here, Kitasato University. And also I'm working as in Nairobi, Africa, Environmental Wangari Maathai Institute for Peace and Environmental Studies, University of Nairobi. And also, I will be University of British Columbia in Vancouver, Canada, as a visiting associate professor from next April. And topics I talk: background advantage of using geographical information system, and data sets, and relationship among temperature, precipitation, and fertilizer for major crops such as maize, rice, soybean, and wheat, and future projection for major crop yield, and how to reduce greenhouse gas. So I'm going to give a talk, 5 topics today. My background, let me talk very quickly. My background is geophysics. Geophysics is meteorology, climate change or meteorology. And I got my bachelor degree at Department of Geophysics, Faculty of Science, Hokkaido University in north parts of Japan. And the atmosphere of Hokkaido University is very similar here in Jirin. So I'm familiar with the atmosphere. And also, I got Master of Science, interaction between sea ice extent and atmospheric circulation. So when I was at Hokkaido University, I joined the ski team. I love ski very much. So next time, if I have a chance, maybe next time when I come, it's me in Hokkaido. I love ski very much. This is the ski area in Hokkaido, and very wide range of ski area in Hokkaido. So next time, if I have a chance to come to Jirin, I do want to ski. And also, just a moment. This also too. in Hokkaido, the temperature is very cold, almost at this time almost minus 10 degrees or something like that. But I love for that. And I have a son. I have a small son, and I train my son. He is crying. He's 3 years old at this time, and he's crying, and he cries for help to me. So I let my son to ski, but he's afraid too much, and he hand. Potato is the hand, and he got angry. And anyway, sorry. Yeah. And I got a master's degree at the Institute of Low Temperature Science, Hokkaido University, dealing with sea ice extent on the Earth. So you can see the picture of the sea ice in Hokkaido. This is the eastern parts of Hokkaido. In February, ice comes like this. This is a sea, but it freezes. So the ice is floating from northern parts here. And you can see the sea ice. This is so-called sea ice. So I'm working on these topics, sea ice, when I got master degree at the Institute of Low Temperature Science. For example, I can show you the example. This is a Greenland here, and this colored zone is sea ice, and you can see this is Hokkaido, and this is Hokkaido, this is Japan, and Jirin is made around here, and white area is snow-covered area, and this is sea ice area. So the changing, they have the seasonal variation. In summertime, they have more snow cover extent, but in summertime, they will reduce the sea ice extent and the snow area which disappeared. And the winter time, snow cover area increases. Even if maybe Jirin, here in Jirin, you have snow in winter time. So they have the seasonal variation like this and changing every day. So there are data sets provided by National Sea Ice Center in Boulder, Colorado, in University of Colorado. So I'm using these data sets and trying to figure out the impacts of sea ice extent and atmospheric circulation. And also during these days, as you know, this is a trend. Because of the global warming, the sea ice extent is dramatically reducing year by year. And I'm surprised. I think it must be much colder at this time of the year here in Jirin. But I think it's not so cold. Even today it's still hot, still warmer. And also, very interesting story is you will see there are open sea here. There's open sea here. So the ship from Europe to Japan or China, the ship can easily move from Europe to Japan. If there is a sea ice here, the ship must go this way beyond the southern tip of South Africa and then Atlantic Ocean and then reach to Europe. So it takes 40 days at least from here to Japan. So when we have a war, we around the beginning of last century, Japan and Russia fight each other here. So the Russian Baltic Russian warship coming long distance this way and come here to fight the Japanese army here. But they take 40 days at that time. So nowadays, the sea ice in this region is reduced, and there are pirates here. Somalia, the economic condition in Somalia is pretty bad. So there are many pirates here. So the ship passing by this way is often attacked by the pirates. So Japanese company want to use boats using this way because the sea ice reduced around here. And sea ice plays very important role for the climate change. When it freezes, when water becomes ice, they will provide the air, the heat. So the sea ice plays very important role. And if there is sea ice and snow cover here, the sun shines, the sun comes to this place and deflected to go outside. So that means global warming will not happen in this case. So this is one example. And I started to work for the Japanese bank and making reports for government or supporting company to run its factory in Asian countries. And while working here, I got a PhD at the Graduate School of Global Environment Engineering, Kyoto University. And then I started work as an associate professor at the Tonjin Tashi for a couple of years. And then I now working for Kwansei Gakuin universities. And I'm teaching at my university electronic commerce, like information technology and marketing, or global risk management, or socioeconomics and environment topics. So I'm teaching various kind of matters at my school. So nowadays, more and more people are eating more foods. And this newspaper, this coming from a China Daily Post, written in English. I got it in Beijing while I'm staying in Beijing around year 1995, almost 15 years ago. I got these articles at the Beijing. At that time, dry weather and urgent demand for rice clothes. There are this kind of facilities. So their economic development is going on. So I will show you what will happen if the economic development has happened. Many pictures. I changed a little bit topics. I did this Monday because I heard that you are undergraduate and you don't have a handout with you. So I will show you the example very slowly. So I hope you will easily understand what I say. For example, this example is coming from the FAO stat. FAO. Maybe some of you might heard of FAO stat, FAO, Food and Agriculture Organization, United Nations. And the headquarters is in Roma, in Italy. So they are providing the data sets of the food intake. So you can see, I will show you the demand for food in each country. And this suggests food intake, calorie food intake, calorie per capita per day. In one day, how many calories are taken by people? And this is the unit is calorie. And this value is very important. For the human to survive, for the human to live, at least 1,500 calories per capita per day is required. But you feel very hungry if you only can take 1,500 calories. At least you need 2,000 or 2,500. You know that this is a wheat, like a pasta. Italian people eat pasta lots, or bread. Bread is made from wheat. And rice, and maize, and millet sorghum. This is orange line is the roots and tubes. And this is sugar and honey. And this line is fats and oil. Fats and oil plays a very important role for the human health. If you take fats and oil too much, you lost your health, bad health. You become too fat sometimes, too much weight. And fruits and vegetables and other vegetable foods and alcoholic and beef, sheep, pigs, poultry is something like poultry is a kokekokko, the bird, kokekokko. And other animal origin foods and fish food. This is the world. From year 1961 to year 2000. So let's move to the round trip tickets. World tour. Okay, this is North Africa, in Algeria, Morocco, Tunisia, Libya, Sudan, and Egypt. So this is Algeria. In Algeria, many people eat wheat. And because of Algeria, the economic development can be achieved. Morocco, many people eat wheat. Tunisia, and Libya, and Sudan. Sudan sometimes the economic condition is not so good, and there were war in the country. And sometimes people die in Sudan because of the hunger. Egypt. Egypt, many people eat wheat because they eat bread, much bread. And West Africa have this kind of these countries, and Mauritania, Cape Verde, Benin, Burkina Faso. Burkina Faso is also the very poor countries. They are not so rich. And Cote d'Ivoire and Guinea. Guinea, they eat much rice in Guinea. And Mali, Niger. You know, in Niger, their food intake is less than 2,000 sometimes. So Senegal, they eat rice. And Togo, and Gambia. As you know, in Gambia, there's a rice production. They took rice here. But around the year 1990 and 2000, the wheat dramatically increased suddenly. So this means that the food support is coming from outside of Gambia, because any troubles have happened in Gambia. And Ghana, Guinea, and Liberia. Liberia also, the wheat is here. Liberia, Nigeria, and Sierra Leone. This Central Africa is Cameroon, Chad, Congo, Gabon, Congo Democratic People, this kind of countries. So Central Africa, they are not so rich here, you know. And they are eating more roots and tubes, like potatoes or those kind of things. And Chad, and Congo, and Angola, and also this is Eastern Africa, Burundi, and Rwanda, and Malawi, Tanzania, and Mauritius, Zambia, and Zimbabwe, and Mozambique, and Ethiopia, and Kenya. Kenya, they are eating more maize in Kenya, and Madagascar, Uganda, and Somalia. Now Somalia used to be a very nice country, but now they are producing more and more pirates here because they are suffering from very serious food shortage during these days, this year and last year. And they don't accept United Nations activities. So many people are dying in Somalia. In South Africa, the level is relatively high in South Africa. And Namibia, and Swaziland, Botswana, and Lesotho. And Latin countries, Costa Rica, El Salvador, Guatemala, and Honduras, Nicaragua, Panama, and Mexico. Mexico is a very rich country. They eat lots in Mexico. And Cuba, sometimes they are losing their food intake. Haiti and Bermuda, South America. Argentina is also rich in food intake. And Brazil, Paraguay, Uruguay. And Chile is also nice. Bolivia, Colombia, Ecuador, Peru. And in Asian countries, you know, we have two sides. Those countries who take wheat, and also those countries who take rice. So Near East, Afghanistan, they are eating more wheat. And Iran, Iraq. this is a sudden drop in Iraq because Iraq is a very rich country until the war has happened. The war has happened in around 1991, so the food intake is dramatically dropped. In Jordan, Lebanon, Kuwait is also dramatically dropped because of the war. And Syria, Turkey has wheat, they eat wheat. And Yemen, Israel, and South Asia, India, people are eating wheat and rice. And Nepal, they are eating also wheat and rice and maize. And Pakistan, they are eating wheat. And Sri Lanka, and Cambodia, in Cambodia, most of the people, they are eating rice. And this slide is very interesting. In Korea. This is South Korea, and this is North Korea, sorry. This is North Korea, and this is South Korea. At the beginning, the situation is the same, but nowadays, they have the big differences here. And maybe some of you might be interested in a soccer game. And Japan, the fight between Japan and North Korea will be held mid of this month, mid of November in North Korea. And this is Mongolia. And Indonesia and Laos. Indonesia and Laos, they eat more rice. And Philippines also they eat rice. I have sometimes going to Philippines to the International Rice Research Institute, and they taught me that the people who live in Philippines, they eat rice 5 times a day. In the morning, they eat rice, and around 10 o'clock in the morning, they take a break, and they eat rice cake. And afternoon, they eat rice. And at 3 o'clock, they take a break, and they eat rice cake. And in the afternoon, in the supper, they eat rice too. And at night, they eat rice. So always they are eating rice. The people who in Philippines, and Malaysia, and Myanmar, and Thailand. Thailand is also many people are eating rice. But as you know, in Thailand this year, they have a very strong floods event as now going on. So I heard that 6 million tons of rice cannot be produced in Thailand. So it is said there must be a serious shortage of rice this winter. And Vietnam and China, Taiwan. This is China, Taiwan. So because of the economic development, they are reducing rice and increasing the wheat. And China mainland, your countries, China mainland, you are eating more and more wheat. And rice is almost the same. Also, this yellow area is alcoholic. So today I got the gifts from the professor, the alcoholic. So many more and more Chinese people are drinking alcoholic during these days. And Hong Kong. The food intake in Hong Kong are a little bit different from that of other areas in China and Macau and Solomon Island, Polynesia, and industrial countries. This is in case of North America. Canada, people are eating a lot. But in USA, people are eating more than almost 4,000 calories per capita per day. American people. And Western Europe, Austria, Denmark, Finland, France, Germany, Greece, Ireland, Italy. Italian people, they are eating much wheat in Italy, and Netherlands, and Portugal, and Spain, and Sweden, and United Kingdom, Switzerland, Iceland. Iceland, many people, they are eating fish here. And Malta Island, and other countries. In Japan, people are taking rice. We eat rice, but rice is reducing. Every year, we don't eat rice, but we eat wheat. Also, we have more fats and oils here. So we have problems in health problems. And Australia, Russia, different. So there are more than 200 countries in the world. So we did the round-trip tickets. Round-trip food intake, round-trip. Very interesting story, I think. And so, we are moving first topic. Today's first topic is this one: climate conditions and impacts on global crop yield. What's happened? I took this picture in Mumbai, in India, last year. In Mumbai, usually we don't have much rains. But last year in Mumbai, we had heavy rain there. Every day we have rains. Very heavy rains every day. Every day. So during my stay in Mumbai, in India, almost every day I had strong rain. So now just I want to show you the example of the data sets of Defense Meteorological Satellite Program data sets, nighttime data sets I want to show you. And I have been working together with Dr. Chris. He's a Dr. Chris for long years, almost 10 years. And he provides me a data sets of nighttime image data sets. So I will show you the example. This is an example of the nighttime data sets. You can see which part. The white colored place is more lights, is here. And black area is almost no lights. So this is a comparison with the income, gross domestic product, income, the economic conditions, country level income, so-called gross domestic products, GDP, and light volume. So there are, if the income increase, there are more lights here. And also this is the gridded population data sets, the population data sets, and the more red areas, there are more people here. So if we compare the nighttime data sets, this is in case of Nepal here. This is Nepal. This is the population in Nepal. So according to the population data sets, many people live here. But as for the lights, no lights is here. So we can say that in Nepal, because we don't have enough lights, so the income level is low or something like that. So I will show you the several example of the DMSP using the nighttime image datasets. For example, this is a change of the night time. They are taking a data set almost every day. So, yes, like this. You can see this is Japan here. And loop. And you can see the value is here. This says, will you please turn off the lights here? Can I go this side? Sorry, or make it darker is better. Just a moment. Because maybe, okay, thank you. You can see the volumes here, F10 means the name of the sensor. And 1992, October. So you can see the change from 1992 to recently. So it's changing. The change from 1992 to 2006 is every month. So you will see in China, you have lights along the seaside, especially along the seaside. And this is Shanghai, and this is Beijing. And Taiwan, in Taiwan, most of the people live in China side, this side. And this is South Korea, and this is Seoul, and this is Busan. But as for the North Korea, black, no lights here. And also you can see the lights here, the fishing boats here. So the fishing season, many ships are coming to the Japan Sea and they are catching the fish. Also you will notice that the lights becomes much higher in winter in Japan, in Hokkaido. It's because of the night ski. We have the habit of taking, we can ski at night in Japan because we have lights at night. So this is a results, proof of the night ski. And also I can show you several examples using DMSC nighttime data sets. Only one example I show you. If some of you are interested in the DMSP programs, please Google just DMSP. So you can see this website. You will find this website. And some of you are interested in the Geographical Information System, GIS. Maybe you can use the nighttime image data sets here. This in case of Shanghai. Comparing 1992, 98, and 2003. Blue, green, red are so-called RGB. Blue means blue area. It only exists in 92. And green area exists in 98. And red area is newly appeared in 2003. And if you mix red, green, blue, the color becomes white. So those areas with the white, the light exists 92, 98, and 2003. So making use of DNSP datasets, you will know which area the light appears. Well, when the light appears, you will know that. And each time up. So this is an example of using nighttime image datasets. And also, I will show you the world travels using nighttime image datasets. For seconds. You will see this is Japan. And this is South Korea. And white area is where light exists. This is generated by NOAA, National Oceanographic Atmospheric Association, and they made a computer graphics using this. And you will see China, upper areas. And you see Tokyo, Nagoya, and Osaka, and Hokkaido here. And we are moving. This is China, Taiwan, Shanghai, Guangzhou, I guess so, and Guangzhou and Hong Kong. And you will see the Bangkok here. This is Bangkok. But nowadays, if you check the nighttime image data sets, in Bangkok, they are losing lights because of the floods. And in China, the light exists along the coast. And this is India. Here is Mumbai. And this is Tibet. And we are moving to the Europe. You can see Scandinavia Peninsula here. And moving like this. Around 100 years ago, the Siberia Railway Pass was constructed by the Empire Russia. And now we are flying over the Siberia Basin, and it's a very long way, but you will see the lights step by step here along the Siberia Basin. And 100 years ago, it takes at least 40 or 50 days from Japan to Europe. But if you take Siberia Railways, you will access to the Moscow in 10 days, 100 years ago. So this is a path of Siberia Railways. So one of my dreams is taking a Siberia Railways and going to Europe by train. not by airplanes. So you will see the lights in the Siberia railways. And also, the advantage of using nighttime image data sets is we can estimate the income by using lights. If those areas where there is more lights, the income must be higher. But those areas without lights, income is not so high. And also we have the shortage, the statistical data sets. If the country is not rich enough, they cannot provide statistics, proper light statistics, because they are not so rich. So there are many countries which cannot have proper statistics. So there are several attempts to estimate the economic conditions. So I will show you another example of estimating the incomes. Very interesting example I show you. For example, I got this file from the professor at the Massachusetts Institute of Technology. I joined a joint conference held at University of Tokyo around 2 years ago, and they are providing a very interesting files. Nowadays, if you have powers, if you have a mobile phone, you can exchange information with your friends by email or sending message. So this is an example of IP traffic. IP traffic outgoing from New York. You will know the black area is at night. And here is the daytime, and here is night. New York is the center of the economic activities. So many informations, many traffic, many computer-based information is outgoing from New York to the world. So from New York, there is London, in Great Britain. Great Britain is also said to be the center of the economic activities. And this is in South America, Rio de Janeiro. Also, they are having the power, they have the receipts. And it's interesting. You can see this is Shanghai in China, in case of China. In China, the IP traffic coming from New York to China is much bigger than that of New York to Japan, Tokyo. So this is the next this movie is incoming to New York. The traffic coming from outside of New York to New York. So you will see many IP traffic information is coming outside New York. From outside to New York. And this is daytime and nighttime. And you will see this is Great Britain. The data is outgoing from Great Britain. And European countries like Paris or Madrid, and Rio de Janeiro in the South America, Rio de Janeiro, the data is going to New York. And in Asian countries, you know there are many places from Asian countries, like Beijing, Shanghai, and Guangzhou. The data is going to New York. So So there are attempts to estimate the economic strength of economic activities using IP traffics. This one is very interesting slide, I think. So these slides have several interesting stories. For example, you have the mobile phone in your pocket. And for example, you are using a mobile phone every day. And this is in case of the experiment conducted in Amsterdam in Holland, year 2007, December the 28th at 6 a.m. And the level suggests the intensity of using mobile phone. So the 2007, December 29th at midnight, no people using mobile phone. But during the daytime, they're using a mobile phone. And December the 30th, during the daytime, they're using more mobile phone because they are communicating. And this is the December the 31st and New Year. At the New Year periods, they're using huge amount of mobile phone. So this is the same in Japan. If we have the New Year celebration, we use much mobile phone. So this is kind of expressing the intensity of human activities, the slide. So this is also a very interesting story. I'll show you. And just a moment. Okay. And I'm moving, speaking many topics step by step. So, GIS data sets. So, now we are moving to the first topics, the impacts of crop yield and climate change. These are data sets of Fawstat. Maybe some of you can access to this website. Just Google Fawstat. So you will see this kind of website. And you choose the countries, and you choose the year, and you choose the products, and you choose the content, area harvested, yield, production quantity, and seed. So these are top 5 major crop producing countries in the world. The major crop is defined maize, soybeans, and rice, and wheat. As for maize, we are producing second largest producing countries in the world. And soybeans is the 4th largest. And rice is the top. We are the top rice producing countries in the world. And wheat is also, you are producing wheat. And I use the precipitation data set. This is an example of the precipitation data sets. From year 1961, January, to 2009, December, by monthly base, monthly precipitation data sets. And also this is the monthly temperature data sets. We can get it from Climate Research Unit, University of East Anglia in Great Britain. And University of East Anglia is one of the best universities in the world. and they are doing the IPCC activities, International Panel for Climate Change, IPCC, so-called IPCC activities. And also, this is a vegetation data set, like this. Each has a vegetation mosaic here. So I will show you the example of the GIS data sets of vegetation mosaic. Maybe some of you might be interested in using GIS data sets for your future. This is an example of the GIS data set. You can see the maps here, and you can highlight the places like this. You can see, move something like this. And this is the map of China. And this world cities, these points, these circles suggest the population. So in China, Beijing and Shanghai, the population is more than 5 million people. And Seoul is also more than 5 million. And you can see Jilin here. Jilin and Harbin is here. And rivers, states and province. And you will see, this is the vegetation map. So there are values in each cell: broadleaf, needleaf, mixed forest, shrub, sparse vegetation, and paddy field, and cropland. So if you highlight along the Jilin, for example, this is Jilin. This is Jilin. You have the urban areas here, but along the Jilin, there are so much cropland is here, and some places are paddy field, and others are broadleaf and deciduous forest. So there are data sets of the GIS data sets, something like this. And the size of this vegetation data set is around 4 gigabytes. So making use of the GIS software, you can handle with this kind of data sets. So maybe some of you might want to know the advantage of using GIS. So I will show you the example of using GIS from my students' graduation thesis. Okay? This is an example of my students in Japan. In Bangladesh, if you access to the website of flood maps, this is flood maps, you will know in which place are under the water. This is, for example, 0 meter, and 1 meter, and 3 meter, and 5 meters, and 10 meters. If you access to the website of flood map, you will see easily. You will know your house will be under the water or not. So my student, he is using topographic data. Topography, I mean the that area is high or low. And also population data set, topography and population and vegetation data set. So making use of topography data sets, we will calculate the area of under the water. And this is a vegetation data set. And we can generate a paddy field. So paddy field information with 1 meter rise topographic data sets, we will calculate the area lost by 1 meter sea level rise. And also using population data sets, we will see 1 meter increase resulting in how many people will be under the water. So this is 3 portions. This is a map of Bangladesh, around the map of Bangladesh. And this area, the topography is higher place. And this is lower place. And 1 meter rise, this value, around 40,000 square kilometers, will be under the water. And this is the population. If it happens, almost 13 million people will be under the water. And in Bangladesh, the production of rice is $80 billion a year in 2007. So this is a vegetation data set. And there are regions from 1 to 20s. And this is paddy field. So this is paddy field. And 1 meter sea level rise results in 5,000 square kilometers of paddy field with a sink, with under the water. So this is the results. Almost 30 million people lose a place to live. And 10% of the Bangladesh area is under the water. And they will lose almost 0.9 billion US dollars. This is an example of using GIS datasets and the advantage of using GIS datasets. So, we could use a GIS dataset. This is a precipitation and temperature datasets. And this is a vegetation datasets. But from vegetation datasets, we could generate the crop areas. So on the GIS softwares, we multiply precipitation datasets and temperature datasets with vegetation on crop vegetation areas. So we will figure out the temperature change and precipitation change on cropland. So we could generate this kind of data sets. And also, University of Wisconsin in USA, they are providing cropping calendar data sets. This is an example of the rice planting, days of year. In which day of the year rice plant started. So this is so-called cropping calendar information. So making use of these data sets, for example, in India, maize. Also maize plant start in June. And harvest start in November. And rice, soybean, and wheat, the plant starts in June. But the cultivation, harvesting area is a little slightly changed. And then we could generate the data set, something like this. This is an example of China. From 1961 to 2009. And yield. Yield means how many kilograms per hectares we could get. So maize, rice, soybean, and wheat. And also the fertilizer data set is here. And temperature, for example, this is 1961. The temperature in January to December. And precipitation from January to December. So making use of the cropping calendar, we could calculate the accumulation of the temperature and also the accumulation of precipitation. So we can make a formula based on this spreadsheet. So we have two cases. One case is case A, temperature, precipitation. Oh, would you please take this? これでもできますか? Thank you. Sorry. Sorry. This is case A. And this is case B. So case A is yield is a function of temperature and precipitation. And case B is a function of temperature, precipitation, and fertilizers. And you can see this spreadsheet. And the spreadsheet we have is almost all of the countries in the world. So, but I'm now giving a talk here in China. Doesn't work? In China, it works. In China. So, I will introduce you the results of China. For example, this is a rice yield in China from year 1961 to 2007. And this dotted line is rice yield, actual data sets on the statistical data sets. And this rice yield, calculated rice yield data sets using temperature and precipitation. And this is the rice yield calculated by using temperature, precipitation, and fertilizers. And this is the calculated values. In case of rice yield in China. So now, you are producing, every year, you are producing more rice because you could put, you are getting more money and economic condition is better. So you can buy more fertilizers. So the yield, rice yield is increasing dramatically. And this is a global soybean yield. What will happen near future? For example, if temperature increase, it is not the case. Yield is expected to increase. But those countries listed below, these countries means if the temperature increase, yield will decrease. As you know, you can see Russia is here inside. So that means Russia is producing much soybeans. So if the temperature increase, Russia's soybean yield will decrease. So that's very serious problems. And also this is a precipitation. If the precipitation increase, generally speaking, yield is expected to increase. But those countries listed below, a precipitation increase will result in the decrease of yield. As you know, you can see that China here. And as for the China, if the precipitation increase, you will lose the soybean yield. So this is a very important fact. So future prospect for major crop yield, we calculated for the future projection of the crop yield using a general circulation model's calculations. This is a scenario. We have 4 scenarios. This is so-called SRES scenarios. We have A1B, A2, B1, and B2 scenarios. A1 scenario is we have dramatic economic development. But if dramatic economic development has happened, people don't want to have more babies. So